Welcome to Leetcode's Blind Curated 75, where I'll be solving the top 75 Leetcode questions. So this question is called Remove nth node from the end of list. Given a linked list, remove the nth node from the end of the list and return its head. Say we're given a linked list like this, 1, 2, 3, 4, 5, and we're given a number 2, we're going to want to remove 4. And keep in mind that we'll have to connect the previous node to the nth node from the end of the list to its next one. So 3 now needs to connect to 5, and 4 is irrelevant. So the first time I solved this, I thought, okay, the only way to solve this is to first traverse the linked list once, find the length of the whole linked list, calculate the nth number that we need, so that would just be the length minus n minus 1, and then iterate down the list again, and if the node number equals the nth number, then we're just going to take the previous node, the node that we continually store each time as our previous one, and we'll make that one's next equal to the current one's next. And that does work. Problem with the solution though is it sucks. It's making multiple passes, it's hard to follow, and I also had to have this kind of weird condition here where if I equals not nth and the previous one was none, basically if it turns out the nth node from the end of the list was the first one, I have to actually return the head.next. So I saw a solution that I thought was way more clever, and it goes something like this, right? So let's say that we instead had 2 pointers, right? Get rid of that. And I'll get rid of this. Okay, there. If we have 2 pointers, what we can do is first, I guess, release our first pointer and make it go n number of times. After that, have our second pointer now go n number of times, but in tandem with that first pointer. Once that first pointer hits a none, that actually means that second pointer is at the nth node from the end of the list. So got it? Like, we have this gap, and that's going to be n numbers, and now we're just moving that to the end, where if the first pointer points to the end, now we know that this pointer, whatever it's pointing to, is the nth node. And actually, you're going to have it point to the one previous to the nth node, but that's the basic idea. So let's code that. We'll say first and second, these are going to be the pointers. We'll first equal head, and first thing we want to do is say for for blank in range of n, let's have our pointer move up. Pointer first equals first.next, and we'll do that n number of times. Okay, now one thing to note, if first.next equals none, or let's just say if not first.next, that means it's reached the end, which means that this nth node from the end of the list is actually going to be the first one. It's going to be the head. So immediately we can just say, all right, if that's the case, we'll just return the second node. And given this assumption that n will always be valid, we don't need to worry about weird n numbers given to us. All right, great. So now that we have that, we could now say while there's a first.next, okay, we're going to move both of our pointers forward. So first equals first.next, and second equals second.next. All right, now once first.next equals nothing, now we know whatever our second pointer is pointing to, that's pointing to the node previous to the nth node. So all we need to do is say, all right, second.next, make that equal to second.next.next. And that way now it's pointing to the next one, and we never have to worry about this next going to be pointing to a none, because we're always pointing to the one previous to the node that we're removing. So once we do that, I think we can just return the head and see if that works. Okay, and let's submit that. Oop, okay, if not, Is that alright? If not first, maybe? That still works. Not first, then next ones. Okay, there. Okay, so I guess I messed something up there, but still same idea. If if first is no longer pointing to anything, that means that the nth node from the end of the list is actually going to be the first one. So that's why we can just return head.next. All right, thank you.